All right, in this video, I want to talk more about multiplicity. So I'm going to look at another example, and also I want to just get more practice for you with the x-intercepts, finding the x-intercepts and finding the factors of a polynomial. Okay, so let me share my screen. Here's an example of a polynomial function. It's a cubic polynomial because it has degree 3, and the leading coefficient, again, is 1. Notice that it crosses the x-axis in 3 places. At -4, 0, that's one x-intercept. Another x-intercept is -1, 0, and then also 3, 0. So we have 3 x-intercepts, and from these x-intercepts, we can go ahead and find the factors. So since -4 was an x-intercept, I know that x plus 4 is a factor. So I'm going to go ahead and write that in, x plus 4. And since here we have -1, 0 was also an x-intercept, then I know that x plus 1 is a factor. And finally, this intercept right here, which is 3, 0, tells me that x minus 3 is a factor. And now you'll see I have the same graph here. Now, these factors are all multiplicity 1. They can't be more multiplicity because for each x-intercept and for each multiplicity of each x-intercept, you have to count that as part of your degree. So what I mean by that is this is a degree 3 polynomial, okay? Now, that tells me that I can have at most 3 x-intercepts, and their multiplicity has to be 1. So in this case, I have 3 x-intercepts. If I were to add a power on, like, say, x plus 4 and put a square up there, that would bump the degree of the polynomial up by 1. It would take it from 3 to 4. And we know this is a degree 3 polynomial, so I can't do that. So this is the correct, each of these factors has multiplicity 1. All right, let's play around with this a little bit. What if I do increase the multiplicity? I'm going to get an entirely different graph. I'm going to not look at this graph anymore and just focus on this one right here. So let's suppose I want to, oh, by the way, I wanted to, one more point. Notice that because the multiplicity of this function here, each factor has a multiplicity of 1, it's odd. If you have odd multiplicity, then at that x-intercept, your function is going to pass through the x-axis. So you can see here it passes through, and it passes through. So that means multiplicity is odd, and in this case, 1 is the multiplicity. Now, I'm going to go ahead and change. Let's make this to a power of 4. And then let's put this one power of let's say square. And then finally, let's say cube. Okay, so we still have 3 x-intercepts. We still have 3 x-intercepts. It's hard to see. This one is so, I think it's because it's well, anyway, this one is so narrow you can barely see it there. That's a little bit better. Okay, so notice that at x plus 4, the multiplicity is 4. So that means that it's even, and therefore it's going to touch the x-axis and then bounce back. And same here, x plus 1 square, the 2 is even. So at the -1 spot here, at the intercept -1, 0, we have the function comes, touches the graph, and then bounces back. But over here at x minus 3, the multiplicity is odd, and therefore it passes through the function at 3. okay? Remember the zeros here, the 0 is -4, here the 0 is -1, here the 0 is 3. And so you're looking at the multiplicity for each factor that goes with those, zeros. Now, what is the degree of this particular polynomial? Well, each x-intercept provides a multiplicity that adds to the degree. So here we start with 4, then we add 2, and then we add 3. So together, the multiplicity altogether is 9. That's the degree of the polynomial, okay? So that's how we understand multiplicities and how we can use multiplicity to help us graph it. Because if we know the multiplicity is even, we know it's going to touch the x-axis and bounce back. And if it's odd, it's going to go through.